Hello YouTube viewers, welcome to my channel Science and Technology. In today's show, Rocket Monday, we're gonna talk about Starlab space station. So let's dive deep into it. So basically this puppy, Starlab, it's a what we call commercial space station. The idea is ISS is about to expire. Actually, practically speaking, it already has expired. We have just no alternative. That's why it's stuck. Again, I'm not joking. This happened a few days ago where they're like, okay, the Russian section has cracked. And they're like, okay, it's a hairline crack. If you do not do anything to it, it will crack the whole structure. So they're like, okay, let's drill at the ends of it to fill it with epoxy. That again, it's a normal thing, but point is it's done. Okay, it was built, it lasted. It's like I'm done, brother. I'm done. it has already expired, so we can't keep stretching it even if we want to. You're like, okay, let's push it to 2030. Okay, let's push it to 2035. Yeah, no, it has already reached a point where it's like it's too stressful to stretch it any further. And again, the main hurdle is not the structure that is degrading, is that astronauts inside are not working, not doing scientific things. They are just maintaining the ISS itself. So again, you do not want to look into how much time, effort and manpower it took just to do structural repair. And again, oh, we're gonna update the solar panel, all of this itself is not a big deal. But if too many things are, okay, now ammonia is leaking, this is leaking, it's just like, okay, what's the point? Like, you come there, you are repairing the structure itself, not utilizing it as effectively as you would. So everybody knows that. So it's a joint venture between many players in the field. There are a lot of companies that went into making ISS as it is. So many companies are like looking into some new venture. They're looking at it. And this is a multinational private corporation, as in ISS is built by multiple nations. Like, a lot of money poured into their heart and soul into it. Some provided money, some provided basically actual physical hardware. So a lot of effort went into it. Here's the deal. Who made those things? Country cannot make anything. There has to be company inside that country that makes things. Like, what if those company came together? So this is what we happened here. And this Starlab, it's huge. It can only be launched with V3 as of now, and the space inside is huge. And part of commercial space station, NASA is funding a lot of what you call early design reviews just for this reason. And core focus is R&D space. Let that be clear. That's why you do not see any giant glass dome. It's not designed for that. It's not designed to be a basically it's a workspace. It's a workspace in space, rather than it's a place where people can, like, relax, and you can have outreach program, and you can have billionaires doing tourism. No, ISS was like, figuring things out. This is not that. This is like, we have figured things out, and this is just a workplace. Like, you go there, you work for 6 months, and you come back. It's almost like an oil rig. Like, you go in oil rig, 6 months you work, and you chill down in home 6 months. That's the whole aim. This is the early stage of basically commercializing space. So it's the R&D and manufacturing center. The target is not what you call tourism. And again, that allows them to keep the cost low. So it's a more of like R&D business park. And they're going to have like everything in one go. They're going to have giant solar panel, giant radiator, giant robotic arm, and basically a lot of payload volume. So who are these players? Well, we have Voyager Technologies that are the majority stake, as in 67% ownership. Now, should you take them seriously? Well, here's the deal. They already have something in space, in ISS. So it's one thing to a new company to say, because again, every company at some point has to start from zero. But again, if you have something critical and deadline, you're like, can't take that risk. So in that sort of scenario, this name is tangible, because they are part of a conglomerate that is dealing with nanoracks. Nanoracks are already very profitable venture. They are the one who created the structure that goes into ISS. It's like, okay, you want to do this? Nanoracks deals with the protocol and how the heck this is how your object should be. This is how it should fit. This is how much power envelope it has, cooling envelope it has. All of those. Basically, somebody has to take care of that. They take care of it, and they realized very early on they do not have enough airlocks. So this is a Bishop airlock. They actually have a physical working airlock in ISS that is working, meaning they put stuff, they test it if it's supposed to be tested in atmosphere, and they vent it if it's supposed to be tested in vacuum, as in, like, they can pull it out, expose it to vacuum. And they are using this to launch CubeSats nowadays, because the older CubeSat launcher was very what you call limited. It's like phew, phew, done. This is like much bigger. So they have some actual tangible experience of building something for a space and using that in space. Then you have Airbus Defense. Now, Airbus is not a company like a Boeing, where it's like, okay, Boeing American. Airbus is more like, conglomeration of whole Europe. It's almost like ESA. But again, Airbus is maintained far more effectively. They have major section that is defense and space. That puppy made this puppy. As in, like, they have made habitats of space that went into space and has been there for 2008. And they are the second largest stakeholder, 30% stakeholder. So someone who actually has the ability to deliver something from a private sector, another with a legacy sector where it's like, no, we have actual experience, we are the one who made this and we know how to make it. So that's there. And then they're like, okay, you need robotic arms to do a lot of things. Okay, MDA Space, Canadian Space Robotics are like, we got you back. Now, why does that matter? Canadarm 1 and 2, both of them are made by that. Space Shuttle Canadarm 1 and ISS Canadarm 2, both are from Canada, and they're like, I got you, fam. So if they say they can supply you a robotic arm, you can trust them. On top of that, they have Mitsubishi Heavy Industries from Japan for Japanese wisdom. What is Japanese wisdom? That puppy. So this is Kibo from ISS. That has that airlock for yeeting things into vacuum of space. So there is more than enough wisdom with enough real world experience. So it's like, we can just like, I know a guy. Where is this guy? Oh, it's in the next cubicle to me. Oh, it's like, I can I can look into the archive. Which archive? My own archive. My country will this, my country this. There is more than enough horsepower there that you can pull tangible experience from it. And the new player, it's Palantir. It's like, okay, why the heck an AI company is there? That AI company is dealing with the software. The idea with this space station is not as a completely research. It's based on maintaining production. Production requires a lot of automation. Automation is complex, especially when you are dealing with zero G. So you do need a new software structure, so to say. Which company can give you that? Generally, AI company is good with that. Again, AI is amazing if you limit it. It's like a constraint AI is amazing. It's just that when we are trying to make contender class AI, we have nothing. So what's the design with this puppy? It's huge, 17-meter tall, huge, and 7.7 meter wide. It's a chunky boy. The reason is that's the Starship dimension that they have received from SpaceX, or at least I hope they have received from SpaceX. What does it translate to? It translates to 450 cubic meter of space. It's huge. In one launch, this puppy will have 50% of space available to ISS. And that's it. Like, they're gonna launch it the end. The aim is not, okay, we're gonna launch another module and no. This will be huge. And be mindful, this is huge as in like one continuous volume. It's not like, okay, you have a lot of small volume, because at that point it's almost like there are 2-3 buses that are connected. No, it's huge module. Like, it's a big module with enough leg room. Basically, all 3 axes of travel is free enough where it's like, no, it is big. So the idea is it's decided in cakes. So you have 3 levels to it. You have power level, basically where all the solar panels and all the radiators, everything goes there. That's the power level. On top of that, you have the lab level, which is this system where you have racks, nano racks. And the whole idea is this part would be automated, meaning you would have some places where person will experiment with something. Then you will have cruncher. We're just gonna crunch things. It's like, oh, my job is I make fiber, the end. I do not touch anything else. I just make fiber. This section makes fiber. This section grows silicon. This section grows medicine. That's what it would be. And this will have robotics to help this system. What kind of robotics? Again, that's another reason why they have Palantir in the board. They need someone who can automate this without causing a hazard. The aim is it should be manned 24/7, but if it is not manned, it will not be stuck. It can, like, I got this, I can take care of it. And they have 2 small windows, pair of 2 small window. Again, it is good if you have people inside a tube for way too long. It's bad for their brain. Ask sailors, ask specifically people who have to go to submarine, not good. Having a window, good. So they have some window. I'm like, thank you. Window, good. 2 small windows, better than no window. And again, natural light is always useful. So that is there, and this puppy is designed to handle 4 people and stretch to 8 people whenever you are having crew rotation. So that's the design aim of it. It's a business park. It's like you go there, you work, you come back. And you hopefully robotics would be good enough in this design where it just allows you. It's like, hey, we sent this company just produces fibers for us, and we just get fiber at the end of Crew Dragon. We collect our payload, sell the fiber, make money. So, okay, that's the claim. Claim is free. What's their progress? Well, they started from 2021, NanoRacks, Voyager Space, and Lockheed Martin. And NASA gave them seed funding to, pursue and design the commercial LEO destination. Lockheed Martin just yeeted out of there for some reason, and Airbus, Tokyo drifted inside, and Japan also Tokyo drifted, and Canada also did. And this is a double-edged sword. Let that be very clear. It is good to have an international collaboration because it allows you to have some wiggle room that is unique to having international partners. On top of that, all these partners that are physically there, they have experience, real world ISS experience. It's good for them, it's good for you, it's good. But it does come with Trump firing missile in tariff, all of that. That's also a problem. For example, Trump recently fired a missile. It's like everything coming from Canada, 100% tariff. What does that mean? That simply means the Canadarm3 that they are buying will go from 5 million to 10 million. So that is an issue. And be mindful, they have to be what you call commercially viable. It's not just like a ISS project where it's like, oh, ISS is supposed to be built for $1 billion, it took $10 billion, you give it. It's not that. It will be scrapped if they keep burning money. So there is a penalty of that. However, so far, they should be able to be on the green side rather than the red side. And by 23 February 2026, commercial critical design review has been done as of now, meaning the design freeze has been done. They're gonna start manufacturing it. And so far I have already heard basically Airbus in Europe is already starting to machine the metals. Basically drill bit has touched the machine, not drill bit, end mill has started to touch the shell, so to say. And here's the problem. When you're taking NASA money, NASA comes with a deadline. The deadline is thou shall do crew orbital flight before 2029. Why? Again, NASA aim is not this. Basically, ISS goes kaboom, a new station comes in 2035, that's no go. They do not want that de-winging that happened after Space Shuttle kaboom. When Space Shuttle fell, there was no replacement. And no replacement was even ready. Technically, they should have been ready. They paid for two players, Boeing and SpaceX. SpaceX did deliver, but took way too long. And Boeing, I have no idea what the hell is going on with them. But again, NASA does not want that to be repeated. That's why they are trying to have multiple companies going on it. So the idea is you must have overlap, as in like by 2029, when they are almost stripping out ISS, it's like, okay, what do we have to save, what we have to remove, all of that. At that time, there should be another space station with American astronauts, with American vehicles. So they do not lose the space infrastructure on ground that has been built. The gap is not acceptable. Like fundamentally, even a gap as little as few months could be brutal. So that is there. However, while I can trust the company may be able to deliver this, maybe, again, if you have Airbus, they have a good reputation of getting things done. So likely, and again, design review has been done and nothing is too magical in this, where it's like, okay, like all the designs are like what you call very calm, very subtle. So it should be doable, but they do not have Starship, and Starship's biggest problem is it's only designed for one thing: do Starlink deployment. And like, okay, but what about the Moon system? They do not require doors for that, and I'm pretty sure that's why he's so hell bent on the fact that okay, we're gonna refuel this, because there is no place for door. The payload fairing, it cannot be done easily. You have a fuel tank on front, you have giant mechanism on the sides. How the heck you gonna put anything else? Like the door, like whenever you see a normal rocket fairing, it's like, yeet, free space. There is no free space. Like you on the back, you are locked. On front, you have fuel tanks. On the sides, you have that. One side, you have heat shield. So that gives you a very, what you call, it's not that you are dumping powder in space. So that whole volume will have very poor utilization. And they have not even a single concept of it. Like this is how the system will, and again, they're talking money and taking what you call booking for deployment. I'm like, again, can they do that by 2029? Doubtful. And be mindful, they have to do lunar mission first. So even if the Starship works, the priority would be lunar mission, because that also has that deadline, 2029. It must do that. So I'm very skeptical. Now, is there a backup option? On paper, there is a backup option, Blue Origin New Glenn 9X4, this puppy. It should be big enough that fairing should be flexible. And that fairing is normal, yeet fairing. You have a fairing, you have no fairing, done. Not this like. So let's see what happens. Again, I'm in this scenario, I'm ironically more worried about the rocket that has to launch this rather than the structure that has to be built. Now, money is the critical part here because we are reaching a final stage of space. Either the space becomes a die-out experiment where it's like, oh, we used to do that and then we gave up, or it becomes the new seed that will happen in basically 2030 to 2050. So the idea is you must have a profitable revenue generation. Let that be very clear. Revenue generation is easy. AI companies are also saying, we have revenue. It's like, bro, you are burning billions and you have millions of revenue. Does not matter. So profitable revenue generation, meaning I dunked $100 million into building this, it should give me at least 110. Again, you will be like, but market gives you, no, fake market gives you more than that. Real world, even that is good. And again, on something that could not work, people are like, fine. Lot of early technology leaps happen like that. So fine. And space can't grow if everything is like government pays money, because the moment government cracks or bad times happen, which again, almost all countries are reaching that bad time, financially speaking. Heck, the times are so bad that 150 countries have stopped having children. They're like, we're not going to exist. That's how bad it is. So yeah, if everything is government funded, it will be cut if bad times happen or bad times become bad enough. So they have to make it into a private system where it's like, it's just a thing and government does the regulation. And again, India seen this, like we used to have governmental airports and it was meh at best, and slowly we privatized all of it. Now it's a world-class airport. I mean, like, it's very shocking for foreigner people. It's like they come to Indian airport, Delhi airport is clean, and I mean toilets are clean. That's how good it is. Like there is person who's maintaining it, all of them. It's great, air conditioned, everything. Then they go outside, it's like, what the hell? So that's the whole point. You do not want that ISS can only work as long as government is burning billions of dollars per year. And again, that should not be required. So station must do things to make money today, as in I start sinking money, tomorrow I should have the money. What are options for making money? Well, Zebra and Space Fiber, I hope you have seen my previous video. This puppy is the closest, that make fiber today, sell it tomorrow. That part is ready to go. So that part is done. This is the closest I've seen anything that, okay, you can only make it in space and it is high demand enough and it is small enough, compact enough that you can actually sell it and make profit. So, okay, cool. One stuff gone. That's like, why don't we sell it right now? We do. Like, the idea has been verified. ISS has this, like actually spooling fibers and all that. It's like, it's actually working. That's how we know. We are literally production prototyping testing. That's how stage we are in right now. So that's ready to go. Then you have some chemical vapor deposition, which is SiG and GaN systems, as in silicon carbide and gallium nitride systems. The problem is that we love these puppies. We want to make all our MOSFET, all our IGBT. I'm not talking about integrated circuit. I'm not talking about chips. I'm talking about elements, as in like, you know, active elements, your MOSFETs, IGBTs, FET, BJTs, those sort of things. We want to use this substrate to make it, but problem is, while we know how to make silicon into like almost absolute perfection, these things are naughty. Even when we do vapor deposition on Earth, there is churning into that. The gases mix around, things happen, and because of gravity, they do not become absolutely perfect crystal lattice. So problem with that, when you grow unperfect seed crystal, the whole ingot is imperfect. So that's the issue. The idea is we're gonna grow this puppy in space, where in 0G you can grow perfect crystal. And again, that is just the seed crystal. You only need 2-inch size of this, like something like that, a disc like this. And it's only like few, atoms thick. But again, it's perfect. Once you dip that into Earth's crucible, ta-da, it gives you single crystal lattice. That is second step. I would bet my money on fiber tomorrow. Day after tomorrow, I'll bet my money on this seed crystal system, because again, they only need to import seed. So it is economically doable. Then there is another idea that this sort of company is trying, VADA, is that there are a lot of medication that exist. Medications are good. With humans, we have weird problems when it comes to health. For example, can we make teeth that are indestructible? Of course, I have that, zirconium teeth. Problem is, we don't have a glue that is indestructible. So like my teeth, zirconium is like, you fire bullet will shatter. But here's the deal, the glue will be like, lol. I drink hot tea and cold drink after that, glue is like, lol. So glue is the weakling. Same with our medication. We have very good medications right now for cancer, but the way we have to inject it, it's so slow and painful. Like you put a drip here, put a bottle there, wait for 4 hours because your body cannot absorb the chemistry. Chemistry is sorted. Then what's the problem? Problem is the crystal lattice of that chemistry, the stuff. stuff, if it grows in 0G, it grows into smaller crystals, which are very easy to digest for our body. But if it grows into the larger crystal, you have to slowly drip feed into 4 hours. So basically, something that takes 4 hours in a hospital or 4 to 6 hours can become just an injection. That can done today. That can happen chemistry, and be mindful, it has been tested in ISS, not on humans, but again, they made it, they physically tested it, mouse testing and all of that, and it does work. That's why these sort of companies are popping up so much. They do not have to create new medicine. Let that be very clear. New medicine will take 10 to 15 years for doing human trials, and I do not think that will ever happen, simply because it's just too big of a risk. Unless like space infrastructure is so sorted, so low cost, that is just like on side we are doing something like that. But again, right now not happening. So right now the idea is things like cancer medication, certain types of cancer medication, and certain type of HIV booster medication. Those medications would be turbocharged if we can control the crystal growth. That requires 0G. We have done it. The testing has been done. It has been done. This is what these companies are doing. Although medication going inside a human body as a normal treatment, that is 5 years away. That would be the, like, day after tomorrow, after tomorrow. So my first is fiber, second is silicon, third is medication. But again, on paper, they can make money. On paper, fiber is like, bro, make it, I'll buy it. Like, don't worry about it. Like, we good, brother, we good. You make it, I'll buy it. The sick things, again, you have to have partnership with Vishay, other companies, IoTs, other company. I keep forgetting company's name. Texas, oh, Toshiba also makes that. So there are a lot of other companies that are like, we make the silicon items. They're like, bro, bring your seed crystal. We're going to make it into a tree. We're going to print money. You're going to print money. Everybody wins. Again, silicon of this high grade can allow you to have electric vehicle motor system that is almost 99.7% efficient. Right now, the world record of motor system is 99.13. It's in India. ABB made it. It's a steel mill. So imagine that sort of efficiency in electric vehicle. That would like, damn, that would be good. And again, I do not mean the motor. I mean the variable frequency drive that will become efficient if we can utilize perfect seed crystals. So that's the hope. Eventually, space will be like a city where you just have factories that are doing unique things and clean environments and like that. This is because again, physics is very clear on this, that there are a lot of features that can only be done if you do not have gravity and buoyancy. Buoyancy requires gravity. So again, I'm not sure about the medication simply because how long it takes and how much medication you have to make. Although they do say that medication amount will also go down. For example, instead of giving 50 mg capsule, they might only need to give you 10 mg capsule. Then maybe you can make enough of it in space. Maybe. I'm hopeful. I want this to be true. But let's see. So this was my presentation on basically this space lab. Hopefully you have liked it, learned from it, and in that case, please click the like button, share it amongst a friend. If you have enjoyed it, click the hype button. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.